We are looking at the flagship ZEB CU400 series electromechanical blasting machine. Specifically, this brass nameplate identifies our visual reference as the ZEB/HU200, a physically identical model that shares the exact same rugged construction as the rest of the 400 series. This is a piece of heavy-duty industrial equipment. It weighs in at 14.5 kilograms, and the entire outer shell is cast from a durable aluminum alloy, coated in a thick gray hammer effect finish to withstand daily abuse. Its core purpose is highly specific. It generates and safely releases an immense surge of high-voltage electricity designed to initiate an entire network of industrial explosives all at once. But this presents an immediate physical problem. To detonate those explosives safely, workers need to deliver thousands of volts of electricity from a safe distance, usually deep inside a mine or out in a remote quarry where there is absolutely no power grid to tap into. When an active blast site is located deep underground, running a standard extension cord is impossible. The environment is entirely off the grid. Because the operator can't plug this machine into a wall, they have to physically manufacture the required electricity themselves, using sheer mechanical force. The value of this heavy metal box lies entirely in its ability to take simple, human physical movement and translate it into controlled explosive power. To understand how, we have to look at the process step by step. The process begins with two simultaneous actions. The operator must press down on the red safety push button, and while holding it down, they begin to turn the machine's side-mounted crank handle. This requires a steady, rhythmic, circular motion. The operator is quite literally pumping their own kinetic energy into the device. You'll notice this silver charging crank is actually completely removable. This is an intentional security feature built into the machine to ensure no unauthorized person can accidentally or intentionally charge and fire the device. The generation of up to 3,300 volts of electricity starts with this single, highly deliberate human action. Inside the housing, the rotation of the crank drives an electromechanical generator. This generator immediately converts the operator's physical effort into a high-voltage electrical current. This diagram shows the internal pathway of that current, flowing directly from the generator into a component called a capacitor. You can think of a capacitor as a temporary storage bucket for electricity. It catches the current produced by the crank and holds it in place, building up the charge up to a capacity of 110 microfarads. The operator has to maintain their cranking motion, continually filling the capacitor until the machine's fire-ready indicator lights up. That light confirms the target voltage has finally been reached. By trapping slow, physical kinetic energy and holding it in suspense, the machine creates a reservoir of pure, high-voltage potential. Once that fire-ready signal illuminates on the control panel, the charging phase is complete. The system is armed. To release the stored energy, the operator turns this central black fire switch. The moment the switch turns, the discharge energy spikes to its maximum value instantly. The current shoots out of the machine and travels down the circuit wires to ignite the electric detonators planted at the blast face. The slow, methodical sequence of building up energy over several seconds is engineered specifically to be dumped in a fraction of a second, ensuring the ignition is incredibly fast and totally reliable. Because operators are managing extreme spikes in voltage, they must adhere strictly to the manual's safety warnings. Any deviation can be lethal. The most dangerous external points on the device are the two terminal clamps, where the detonator circuit wires physically connect to the unit. They are clearly marked with red lightning bolt icons for a reason. The absolute rule of operation is never touch the terminal clamps. If the machine discharges while a worker is in contact with those posts, the massive voltage will cause a severe, life-threatening electric shock. The outer casing can survive the harshest industrial conditions, but the operator's safety relies entirely on respecting those high-voltage connection points. There are also strict environmental limits to consider. If the blast site is inside a gassy mine filled with flammable methane or airborne coal dust, using this standard machine is entirely prohibited. This chart compares a standard discharge with a specialized model. In flammable environments, operators must use a permissible K-model blasting machine. These units cut the energy output time down to less than 4 milliseconds, preventing the electrical spark from accidentally igniting the surrounding explosive air. The entire sequence is an elegant chain of events, attaching a removable crank, physically filling a high-capacity capacitor and flipping a switch to initiate. It is an exceptional piece of heavy-duty engineering that takes basic human movement, amplifies it, and delivers the precise power required to move mountains.